With an off-delay timer instruction, the done bit becomes true as soon as the instruction is true. Timing will not start until the instruction goes from true to false. The done bit will not become false until the timing is completed, when the accumulated value equals the preset value. This is a simple ladder logic program to demonstrate the off-delay timer instruction. When the switch is closed, the done bit turns on the green pilot light immediately, but timing does not start until the button is released. This program makes use of an on-delay timer and an off-delay timer to control a heating process. When the oven on button is pushed, the oven on pilot light latches on. When the oven on pilot light is on, the TON instruction starts timing to create a delay of 10 seconds while a horn is sounded before the heater contactor is turned on. The horn is turned on by the timer timing bit of the TON, and the heater contactor is turned on by the done bit of the TON. At the same time the TON is true, the TOF is true. As soon as the TOF instruction is true, the done bit is true, which turns on a cooling fan. When the oven off button is pushed, the heater is turned off and the TOF starts timing, which keeps the fan on until after the 30-second timing period. Watch as the heater goes through a complete cycle. First, the on button is pushed. The heater and fan will be on until the off button is pushed. The fan will run for 30 seconds after the off button is pushed. The retentive timer retains its accumulated value if the run goes false, the processor is placed in the program mode, the processor faults, or power to the processor is interrupted. When you do wish to reset the accumulated value to 0, you can use a reset instruction. The non-retentive timer's accumulated values would be set to 0 under these same circumstances. This program will demonstrate the operation of the RTO and the corresponding RES instruction. When the limit switch is closed, the retentive timer on will time. When the limit switch is opened, the timer will stop timing, but will retain the accumulated value. Only when the reset button is pushed will the accumulated value be reset to 0. In the simulation, we will close and open the limit switch several times to show that the accumulated value is retained. When the timer is finished, we will close the reset button while the limit switch is still closed. The accumulated value of the timer will reset to 0 and start timing again. In this example, we have 3 timers. The first timer is started when the start push button is pushed. The second timer starts when the first timer is done. The third timer starts when the second timer is done. This arrangement is called cascading timers. Event 1 pilot light will turn on 3 seconds after the start button is pushed. Event 2 pilot light will turn on 10 seconds after Event 1 pilot light turns on. And the process complete pilot light will turn on 5 seconds after Event 2 pilot light is turned on. Three seconds after pressing the start push button, the green pilot light will turn on. 10 seconds after that, the yellow pilot light will turn on. And after another 5 seconds, the red pilot light will turn on. Timers can also be connected in a reciprocating arrangement. When the first timer is done, it will start the second timer. When the second timer is done, it will reset and start the first timer. This arrangement can be used to create a flashing alarm light. In this simulation, both timers are set for 2 seconds to create a flashing timer that is on for the same length of time it is off. The presets could be set at any value to create any effect.